Okay, let me give you some feedback of what we're doing. And apologies to those of you watching that we were a little bit ragged on the edge there. This is coming to you from Modesto Junior College. This is part of a new offering that we're doing through 3C Media Solutions. And we're playing on broadcast here locally in Modesto, California. And so we're broadcasting in television, we're broadcasting on the 3C Media Solutions Network. And today is, and good morning, Shelton, a day that is going to be ostensibly each week a review with the idea of a tutorial is what we call it. So there's 4 days of lecture and then a tutorial. Now today is going to be a little bit different than the typical, and there are several reasons for it. One, those of you watching on 3C Media Solutions missed our first couple days. And I wanted to try to make sure that we did, as we looked at this review today, covered all the topics so you didn't miss anything from the first week. And it's, I think, worthwhile as I looked at materials this morning to talk about a quiz that I want you to take, that it sort of gave me an overview of where we've been, what we've done. I'm going to take time to do that, and then much of the time is for this group in here to ask questions of any problems that they are working on. Now, one of the things that's new that is causing some reasonable level of frustration is doing a computerized homework approach for what we're doing in here. And so we've had some frustrations with that this week. I have also, in terms of what is new for us. But it is the hope that as we do this, it will provide what is promised, and that is better success, better understanding on your part. And this first week, it seems like many of the wrinkles have been, I think, worked out, but as has been observed by a couple of you, this is becoming very quickly across campus a phenomena that would not have been there a year ago. And that is the number of classes which are trying to take your talent at the computer and embrace it as part of what we are doing and try to get some advantages in the process. So for example, if you do a homework on paper and you screw up and you look at your answer in the back of the book and you're wrong, you don't know what you've done wrong. And it's difficult right at that moment to get some directions. But if you are on the computer doing it and you mess up, then you get a chance to see a solution provided to you, step by step. And one of the things I'd like to illustrate once I get my computer in here functioning is that you can go ahead and if you still have a question, reference the book by the exact page. And there is also a lecture that you can watch related to that problem. So there are a lot of things that are to a benefit. We have just scratched the surface by having you answer the questions and put your answers into the computer. Now, because of the difficulties, I went ahead and made the due dates next Tuesday. So you can go back and work on any area you want and get caught up. One of the things that I believe was shared, Rita, you were saying when you talked with the representative from Pearson, that if you have difficulties, you should be reporting them, and there's certain perks for doing that. Check with Rita about that and see what those perks are. But you might enjoy some coffee in the process. Okay, comment I made yesterday, and I want to reiterate today. Starting this week, coming up, you're expected to write out your solutions in a notebook, keep it on a daily log, and then at the end of the week, you're going to check in with Rita. She's going to sign off that the work has been done. And I will then, I think, expect at the time we get to the first test that I can go back and look at your notebooks and it'll have a sign off. Maybe we can do that on the front page or something. And if you need help getting that copied or something, we can do that, something written out. And then I can look at that and say, okay, everything's done. And I have the feedback in the computer, how well it's gone for you. And we can track things a whole lot better. I don't want you getting lost in this process, and I don't want you to become anonymous in this process. So I may ask just at random, I've got a weekend or I've got a night free, I want to see the following notebooks. I'll take them home for the night. and look at them and give you some feedback and try to get some sense of what is happening if your solutions are the way they should be. So that's where we are. And the goal, just so we put that in perspective, is to come out of a pre-algebra and then go into a beginning algebra and be successful. So as we look at things, we're always going to keep in mind how it relates to the algebra that we are preparing for. You're going to find that we're going to cover about half of what would be called the beginning algebra course as we do the pre-algebra. So this gives you a running start, and there are a couple things that you need to keep in mind. It's not enough just to do a problem once. And the problem sets that are assigned sometimes are a little bit short, maybe 7 problems, 20 problems. And I'm going with what is provided to me on my math lab as the problem sets I assign. You need to go beyond there. You need to develop that proficiency, the repetition, to get good at it. Okay? So with that said, let's sort of go back and take a look at what we've done in each section. I want to take a brief overview, and I'll be using the board and the book and the document cam all at the same time. Before I do that, and again, I didn't really spend enough time with this, and I don't know to what extent this is going to work as well as I want, Debbie, but let's hope I get a quick response out of the computer. I would like to show the people who are watching, particularly those who are watching in 3C Media Solutions, because I have not focused on this as much as I might have. But on the screen now, as Debbie cuts to the computer, we have a splash page. And by that I mean here are 5 courses that are all video-based. And the new one in the block, the new kid in the block, so to speak, and this is actually a circle. This zoom I'm doing makes it look like an egg. So think of that as an Earth as an Easter egg. But Math 20 is the home page there. And so this is a place where you can at least figure out where we're going. Now I'm going to come off there for a moment because I clicked in that, and that means it's going to take maybe another 45 seconds for all the security things to happen for that page to come back up. So the key here is if you want to see where we're going and what we're doing on a week-by-week basis, you'll be able to do that on the computer. And the URL for that, and I think I might be able to come up to the top there. Let's go to that, Debbie. It's not as readable as I'd like, but I'll tell you what it says. It says virtual, then with a period, then Yosemite, like the national park with a period. So virtual and Yosemite. After the Yosemite, there's a period, and the CCCAUS stands for Community College, California, United States. So after the CC is a period, after the CA is a period, after the US, no period. That's a fraction line, like a forward slash, and it says JCURL, JCURL. Now what this finally did, it took that long for me to get that web page, so we're faster than this typically, but this is the video-based Math 20 homepage, and what I wanted to focus on is down at the bottom, where we find that there is a link, as I scroll up just a little bit for you, the spring 2009 schedule. And so for those of you who are watching and you wanted to get some sense of where we're going, and I have a lot of things I'm going to try to add to this page that have not yet been done. But this is our first week as we look at it. And when I do that, what you see, and I again will scroll down for you, it's called a week at a glance. And so there was our first lecture, which was the introduction and the chapter, the lecture 2, 3, 4, and what we are doing right now is the 5th lecture of the week, which is the tutorial itself. Now, the board photos have not been done yet. Building this is going to take 300 to 500 hours. This first week, there hasn't been time to do anything regarding this page, so be patient. This weekend, I'm going to try to get a little bit accomplished with it. Now that we've said that, let's look at what we did in 1.1, 1.2, and 1.3. That's what you're responsible for today in terms of a quiz. The first section, and again, we're talking about whole numbers. And again, what is the difference between the whole numbers and the counting numbers? I'm going to ask that as a question, and I'm going to expect an answer. The difference between a whole number and a counting number. There's one minor difference. What is it? And oh crap is not the answer. Okay? What is the difference? Anybody?
Zero?
Yes. Shammer's got it. The zero. We don't consider zero a counting number, but we do consider it a whole number. Now, some people have argued that it should be a counting number because you come into this room when nobody's here and say, how many are there? And you say, zero. You gave me the count. But historically, the whole numbers include zero. We also refer to them as integers, and that is a new phrase that we didn't focus on as much in Math 10. An integer. Positive integers are your counting numbers. And what we learned when we worked with graphing in the last semester, that there are negative numbers. So if we take the whole numbers and the negatives of those, we get what are called the set of integers. So we are focused in this first section on the whole numbers. And in doing that, place value is the big issue that we have already looked at. And we talk about expanded form. We talk about word form. What we called positional notation is being called standard notation. So let me go to the board now, Debbie, and let's just go through a bit of a review. So we have standard or positional. So if I look at some particular number, and there's no particular reason, but what comes into my mind is 1492. Columbus sailed the ocean blue. But anyway, standard form, positional form. And we put the comma typically there. And again, keep in mind, depending on where you're from, it may be a period rather than a comma in some countries. And then there's a standardized notation in print where we sometimes just leave a space. But it gets confusing if we leave spaces when we write them on boards and on paper. The expanded form, we reviewed that. Now these are technically what we could put under the genre of notation. And so this is just a brief review. And so the expanded form, we looked at the place value of each digit and multiplied the digit by its place value. Now you could have done this, and what was the alternative in the third section? To use the power of 10. So that was simply another way of doing it. You must remember the plus sign, and this is the 4 times 100, or 4 times 10 to the second. Then we had the 9 times 10, the 2 times 1. And I also had here 9 times 10 to the first. And to the extent that I mess up something there. Go ahead, Michael.
Could we also just write 1,000 plus 400?
Okay, I'm going to talk about that. There's a question that's been asked. I'll address the question in a moment, even though you may not have heard it, so I can at least get this part done. Now, the point being, 1 is 10 to the 0. So let me just move over this way just that much, and we can keep everything on the board and see me. I feel like one of those talking heads down the corner of the screen. But this is with exponents, and I like to see the 10 to the 0 at the end if you're going to do it that way. Now what Michael asked, could I technically do this, is what we call expanded notation. And the answer is yes. However, if you do it this way, one, I believe our current text does not use this form. And if you tried entering that as an answer in my math lab in the computerized base, you would get an error. I don't like this form particularly because it doesn't lead us into algebra. The reason for stating that, regardless of the base, we could replace the 10 with a 6. Well, because of that silly 9, I couldn't. But if we looked at a base in general, I could say that in general, you're going to have a number times the base to the third power, and then another number times the base to the second power, and another number times the base to the first power, and then another number times the base to the 0 power, and we don't use x's at that point because this is a generalization. So we would say 1b to the third plus 4b to the second plus 9b to the first plus 2b to the 0, and suddenly we have an algebraic expression that is called a polynomial. That's why I like the transition from here, because when I get down to here, it gets an easy segue. You'd lose it going to this. But the last version of our Math 20 book allowed you to write expanded notation this way. But understand, I'm looking ahead. Now, that was expanded. And of course, we had the word form. And the word form, and somebody asked, well, how do you remember the expanded notation? And I think it was Marisol from last semester made the comment to me in here, it's this, the expanded form. So you expand and things move separated out. In terms of the verbal form, think of writing a check. How you'd write it out in a check. Question, Natalie.
Before we move on, can you spell that, the what?
Oh, a polynomial.
Yeah, polynomial?
Okay, let me slide over just a little bit, Debbie. Polynomial, like Polly wants a cracker. Poly, gnome, eel. And that's going to be a real important word that is going to become part of your vocabulary from today on. A polynomial. Now, since you bring this up, okay, remember when we had the number of bars over the M to name things, and we talked about a billion because bi meant 2, and we had a trillion because tri meant there were 3 bars, and then we had quadrillion because there were 4 bars. Well, I'm going to have the number of terms. So, you open the gate for me. Each of these things I added are called terms. So if I have an expression and I add things together, the things I added together are terms. So in this case, I'm just generalizing. There are 1, 2, 3, 4 terms. Thank you, Debbie. 4 terms. But if there were only 3 terms, I would call it a trinomial. If there are only 2 terms, a binomial. And remember the monocycle? We'd say a monomial for 1 term. So monomial, binomial, trinomial. We don't say I can't even say that. Quadomial. Nobody says quadomial. They just say a polynomial. So if you have 4 or more, generic phrase is polynomial. What's interesting, a binomial, trinomial are also considered polynomials. So it's sort of a generic phrase. Anything that looks like this will be called a polynomial. But if it has 3 terms, trinomial. You got more than you bargained for. Okay, now, remember when we write the check, we write things out with the usual letters of the English language. It would look different if we did it in Spanish. It would look different if I did it in French. But we would say, in the verbal form, I guess I'll just write here, verbal. And again, I like the phrase verbal better than I like word form. It's like weird form. Verbal form, verbal notation. And we don't use that very much in algebra. So this is one of those that takes a little less import. But just as a reminder, we would say 1,000. And again, I have not been very picky about having what? The commas. I think your text is. So you have to be careful when you write your answers. If you get what you think is the right answer, but your punctuation's wrong, that could be why you got kicked out. It's very unforgiving. 1,000, comma, 4, and I'm just going to write another line here so Debbie doesn't have to pan to the right. 400, comma, 92. And I believe that's the way that would... A dash has to go between the 90 and the 2. It doesn't get accepted?
No comma
Okay, so I have an argument going on here whether they use commas or not. If you don't get it with the comma, put the comma in. If you put the comma in and it's not going, take the comma out.
There's a hyphen.
A hyphen or a dash, 92, like that? Okay. I don't like that because it looks like -2. But anyway, if that's all we're caught up on, we're doing good. Okay, so don't let that blow you away. But it's just a reminder we've done that. Now, in addition to that, in this set of problems, I think the only other part was place value, where you had to look at this and say, name the number whose value is 100. So, thank you, Debbie. Just there you go. Given this number, can you name me the number? Numeral would be better. Name the numeral you see whose value is 100, and I see this being shown me 4. Okay, that's correct. So place value. None of that was new, right? But it's nice to talk about it again. And to remind you that if you put your answers in a computer, they're going to have a tendency to be picky in terms of the programming they wrote, because they have to agree in some style, some format, and if you don't meet it exactly, then even though you're right, it'll come out wrong. We have one more topic here, medians, correct? The median of a set of numbers. So I'm going to just choose some numbers. Ephraim, give me a number between 1 and 9. 8. Are you awake this morning? Ah, I can tell. An 8. Isaac, another number.
7.
A 7. Okay, Shamra. 2. Next number, Emily.
4.
Ah. You were getting them to me in the order, and I didn't want to do that. So now I want the median of this. What's the first thing I have to do? No, not add them up. You're thinking of the sum. Sort them from the smallest to the largest, or from the largest to the smallest. See, if this was going down what? Largest to smallest, and you wouldn't have to do anything. That bothered me. So we would write 8, 7, 4, 2. That's called a sort. S-O-R-T. And don't get blindsided by that word. It looks simple. I give you 200 numbers, and they're big numbers, and you're supposed to sort them. It is not easy. You need a program to help you. I have an even number of values. So how do I find the median? Because the median is with 4 values. It's 4 plus 1 over 2 is the location. That's not the value. That's where it is. So the location is at 2.5. So there's 1, 2, 3. 2.5 is right in between here. So what do we say that you're supposed to do?
Add 4 and 7 and divide them by 2.
Okay, I heard it. A couple of you say, I average the 2 middle. I add the middle 2 and divide by 2. You're saying it in different ways. So 7 plus 4 over 2, that's 11 over 2, which is 5.5. And what notation do I use for the median? Symbol. Not okay, when I said notation, it's not positional, it's not expanded, it's not verbal.
Like this.
If you could see what I just saw, you'd understand exactly what is being said. It's X is what you made with a squiggle, a tilde. So we call it X tilde. Then I added a little bit more just to make it interesting. And this is what Ephraim was talking about, where we add them all up, and that was called the what? The mean. Remember, this is the median. And the median is what we call an average. Michael.
Since it's an even number, wouldn't we have to find the mean of...
The middle two.
Yes.
Yes, that's another way of saying it. Well stated.
The median is the average, or it's the
No, the
middle?
median is a value in the middle of the distribution when it's sorted. If it happens to be a particular value, then nothing has to be done with an odd amount of data. Now, the mean, M-E-A-N, designated by the X, and then Emily's doing in sign language for me. That's called X bar as opposed to X tilde. So tilde and bar. I can't pass this up. I'm jumping ahead 2 semesters, 3 semesters, but it's worthwhile. I want you to add up all the numbers. The notation is a Greek letter. It looks like an M on its side. It's called sigma. So we say sigma x over n. And that's the formula. And then I'm supposed to add these numbers up. This says add them up.
Wow.
Well, I told you I was. Just a few years. It's just notation. That's a Greek letter. We call it sigma. Sigma x over n. That says add up all the x's. These are called x's, values. So what is the sum? Okay, so we had 15, 19, 21. So my substitution, formula, substitution, answer. And so I have 21 over 4, so it is what? Okay, I want the solution. Thank you. 5 and a fourth, right? Now, why did you say this one, Emily, and everything else has been in sign language? Okay, just being difficult. Notice, okay, you didn't want anybody else to hear you, right? This is the mean. This was the median. Notice the mean is smaller than the median. If we had a lot of numbers and we had a distribution, like your test grades, you have a lot of C's, fewer B's and D's, fewer A's and F's, you get this bell-shaped curve, right? I'm doing an Emily now. Okay, I'm directing. Bell-shaped curve. The mean and the median would come out the same. When they aren't the same, it tells us something about the distribution. And notice here that I have, in terms of values, things pretty well, in the sense this is the middle, and I have a 4 and a 2 below, and a 7 and an 8 above. Okay, so to that extent, I don't have a feeling that if I have, for example, 1, 2, and a 3, and then a 9, the 9's not like the others. And it's influencing, as I said, an average because of the high value. So we compare these two later on, the mean and the median.
It only influences them if you're looking for the mean.
Right. The mean is sensitive to the extremes. Precisely. What Emily's saying, now how you suddenly become so talkative. The mean is sensitive to extremes, the median is not. Where do we use the median?
Like in the housing market.
Housing market for the price of houses. When we talk about economic kinds of things, they want to avoid the extremes and just give you median. That was the first section. Any questions on that? We're okay there? Isaac, we aren't okay.
I'm just confirming.
Oh, confirming.
Oh, man, Mike, right?
Okay. Any other comments, questions? Section 2. Okay, so let me come back to center. For section 2, and again, we're just trying to get a bit of an overview, just nailing things down. What did we add here that we hadn't seen before? What's the biggie? Section 2.
Section 2?
Yes. Section 2, some new things. What were they? Yes, as James says, the properties. And how many of them are there totally, Emily? You've been keeping count? 11 of them. How many have we done so far? 9. We're missing 2. Okay, can you name them quickly as part of this review? Not without looking. Name them without looking.
Cumulative?
No, not cumulative. You're close. It has a commutative. For both. For both.
Associative?
No, commutative for both. Addition. You would be surprised how few people here at the noise level we've generated. Commutativity for addition and multiplication. It means you can reverse and get the same answer. Okay, Emily, associative. What did it mean to have an associative for addition and multiplication?
You can mix them up.
Okay, mix them up. You can start with A and B or start with B and C and get the same answers. Okay, so we had commutative, associative.
Closure.
There's 4 total. Closure said what? Closure for addition and multiplication.
The sum of two numbers.
The sum of 2 what?
Numbers.
What
Or
kind of
letters.
numbers?
A and B.
Real numbers. The sum of any 2 real numbers will be a real number. The product of any 2 real numbers will be a real number. Question, what's a real number? Everything. Okay, that's not a bad answer for where we are, but where we're going, it would be too much. Give me the subsets, the collections that make up the reals.
Oh, crap.
Fractions, decimals,
Fractions, decimals, and
whole numbers,
integers,
integers.
because we want the
What about
negatives in
negatives?
also. Well, when I say integers, that's positive and negatives. When I say fractions, what's another word for fractions?
Quotient.
Okay, that's a good answer. You said quotient, but I want better. Rationals, ratios. Fractions are ratios, hence rationals, but we say rationals because it sounds better. So rationals, integers, and it's not just any old decimal, because I can write a decimal as a fraction. It is the decimals that can't be written as a fraction. Give me an example of one. 2 can be written as 2 over 1.
Okay.
Give me a number that can't be written. What?
The square root of 2. 1.42.
Yes, very good. The square root of 2 can be approximated as 1.41. But
And some junk.
and some junk, I say garbage to come. Okay, it's 1.41 with a little plus sign, meaning it goes on like the Energizer bunny rabbit, but it never repeats and never ends. Those are, what? E is another one, yes.
Pi.
Pi is another one. Very good. E and pi and the square root of 2. We call them what?
What you just called them.
Wrong answer, Emily. Not what I just called them. Michael.
What about 2.71?
2, 8, that's E, but that is stopped at some point, and it sounds rational, but it's not. What? No, how do you say not rational?
Irrational.
Thank you. Irrationals. So rationals, irrationals, and integers. Those are our reals. So somebody says, what's a real number?
Rational.
It can be a rational, it can be an irrational, it can be an integer.
Or we could just tell them 1, 2, 3.
No, if you told them 1, 2, 3, you're just giving a part of the story. Okay? Just remember, here's another thing to keep in mind. 3 sets. All of them are infinite. You can show that there are just as many integers as there are rationals. That's possible. But when you do it for irrationals, there are more irrationals than rationals. So there's 2 different levels of infinity.
But I thought that problem was never solved.
It wasn't. The question was, is there another infinity? And it can't be solved if all you have are the 11 properties of the real number system. It's a non-resolvable question. That was 1954 Cohen at Stanford University. Okay, that's part of what's in 1-2, and a little bit beyond, but that makes it fun.
Closure properties.
Oh, we didn't get them all, did
didn't
we?
finish all the
Okay, I'm
properties yet.
sorry, my apologies.
Closure.
What are the we did closure.
Identity.
What is the identity? There are 2 of them.
Something plus itself.
Okay, A plus 0 equals A. That's the
A plus-
identity for addition.
A times 1 equals A.
A times 1 equals A. That's the identity for multiplication.
And now distributive.
Okay, the distributive is the only one we haven't covered. What does it say? Don't look, tell me. Don't look. Can't look, and you have to tell me.
A times. A, B, and C, group them any way. They all each are the same.
You can take.
Okay, you're sort of saying it, but I'm not hearing it. Debbie, I'm migrating again, like the birds. Okay, so over here. Okay, now let's try it again. James, try this again. You told me something about grouping.
Say A and then put
And B
it
plus C.
Okay, in
B
parentheses,
plus C.
B plus C. Okay, it could then be the same as.
A,
No.
Plus B.
AB plus AC.
Very good. You don't need to put the dots between them or parentheses around. The AB, when you write it together, means multiply them together. Proximity tells you what to do. The sum of the products. Yeah. No, this is the distributive, and this is the biggie. This is the very big one because what did we say we could do with this property ultimately? Not inverse it. I related it to something with primes. We talked about prime factoring. I want to factor. Oh boy, I'm glad that the question got asked. Okay, Debbie, I'm going to go back to my omials. Okay, so you just nod. Okay, back to here. She didn't know where the omial was. The polynomial. Okay. Polynomials, we want to factor. So when I get this mess, as I slide back this way just a little, I'd like to take that four-termed expression and write it as a product. We're going to do it with the distributive property. So this is the biggie. That's where and that's what makes algebra so exciting. Translation, frustrating. Difficult, yes, that's where the difficulty comes in. But that's anticipating problems we don't need to. Okay, I'm back center. Does that, and you're, okay, just bring me in with it gradually. There we go. Notice how smoothly she does that. A pro. Now, the other things in this section, beyond the properties, have to do with estimation, right? And that's where you ran into some trouble on the computer. Because if you're going to estimate something, we had to agree what we meant by rounding. So if I were to look at the other board, which is where, I don't know if I will or not. Hold on. Don't move anything. We'll go back to the document cam. We'll do it that way. The direction involved here, that's what I'm hunting for. The question is what page, and I have no idea at the moment, James. But I'm trying to get there.
What page for what? For the distributive?
No, not the distributive. I'm wanting to do the estimation, and I don't see it. I'll just look at a problem here. The directions are as follows. No, just a minute. Here is the phrase you see as we go to the doc. Estimate each sum by rounding, and then find the actual number. So unfortunately, and I don't like having this book because it has solutions provided at times where I'd rather not see them, but for the moment it helps us what we're doing here. If you're estimating, you'll notice the answer is supposed to be 80,000 when we estimate. Well, the argument is these both have the same number of digits, and so we want to write this with what? One non-zero digit. So if I write this first one as one non-zero digit, I'm rounding off to the nearest 10,000, so that becomes 50,000. Same argument, this becomes 30,000. Then you add the 30 and the 50,000, you get the 80,000. And then, of course, you were supposed to actually get the answer, and that's where you were supposed to end up with this 84003. That was the only thing in this section that you seem to have trouble putting into the computer. And there seemed to be a glitch that got resolved. The only other thing we've introduced is the idea of solving an equation. And an equation had an equal sign between an expression and a number. And so if I look down here at the bottom, and this is just a couple problems that I assigned. They look different on the computer. But you had 8 plus x was equal to 12, and so you were supposed to note that if x was 4, it made this left side the same value as the right side, so we said this was your solution. Now, there was a related equation, correct? You could say it's x equals 12 minus 8, where you subtracted 8 from both sides. Now, that is where I think the author doesn't quite run as truthful as I'd like. He makes it sound like you're doing something magical. What we're saying is two things are equal, and I do the same thing to both sides, it's still equal. So I can subtract something from both sides, add something to both sides, and it's still equal. That's the mathematics. And that's called a property of equality. I can add the same thing to both sides, get the same equality. By the way, I can multiply both sides by the same number and have it equal as long as it's not 0. Okay. Now, coming through here, let's go to section 3. And in section 3, and that building's not falling apart next door. I think they're doing something to the room next to us, and it sounds like things are grinding. We're what? Still no lights. Wow. They want you in the dark. Okay. That's the control room that's in the dark. That's scary. Okay. Now, the other properties, we've gone through those. We're in 1.3 is where I guess I jumped ahead a little bit. So if we take a look here just for a moment, and I think I want to make a comment here. This is, as we go to the document cam, this is the property. That's too far. I'll bring it down. This is the property on page 29 that James was just referencing, the distributed property. Now, what is done here that I don't like is this is given like a separate property. That is A times B minus C. Let me tell you the secret. I can still do that on this board. B minus C is the same as B plus negative C. Okay, Isaac's asking, how can they be the same? If I think of 5 minus 3, it's the same as 5 plus negative 3. You get 2 either way. So we don't need the separate subtraction statement. But if you're not wanting to confuse the issue, you run 2 statements. I don't like that when you have to have 2 statements where one will do. That's called paucity. Getting by with as few things as you can. That's what we do in a depression. Practice paucity. Back to center. Okay. In this section, number 3, we had the exponent bit. This, for us, and I know that people who are watching say, well, I didn't have you last semester, so son of a gun, you're cheating me. Okay, here is the secret. If you multiply 2 times 2, there are 7 2's up here. So the 2 is written as a factor 7 times, and if you want to convince yourself, do that, and you'll get a 128. But the shortcut is to write 2, which is called the base, okay, to the exponent of 7. So this phrase we understand to mean this product. So it's simply a shortcut. And so you had a bunch of this. Now, you were reminded that you'd seen this before with powers of 10. Now, the unfortunate wrinkle here is that you think of that power of 10, okay, I'm going to jump the book momentarily, as being the number of zeros here. And that's a nice shortcut. 6 zeros after the 1, 10 to the 6th. But it's not that you have the 6 zeros, it's that you had what? The factor 10 6 times. Coming off there, then this again, and this is what I was referencing earlier, naming large numbers where we had the billions, trillions, and quadrillion. And I had referenced this to the number of bars over the M in the Greek symbols, well actually the Roman symbols, my apologies, that were used to represent large numbers. And then we had the Google and the Googleplex. Now, coming off that for a moment, just still staying in this one board, and Debbie, I'm hunting for space, down here in the lower right corner with the other camera. Okay? Over here, if I had 1 million, that's a million, the M stood for 1,000, and 1,000 thousands was with a single bar over it. So if you had 1,000 thousands, you'd have another bar, 2 bars. So the 2 bars, otherwise having another group of 3 zeros, would make this, okay, we would have 1,000, million, billion, and I'd have M with 2 bars like a bicycle. So back to the document cam. And that is where we get the notation. So coming off that.
Billion is in $2.
Yeah, M bar bar was the billion, and M bar bar bar, see, M bar bar bar, 3 bars, would be a trillion. That covered the material other than finding, and just a comment here, we finally finished off looking at things like a square, and so we remember the units and formulas. And in this case, what I think we are doing is looking at like the area, okay, or the perimeter, but we have, and I didn't stress this very much as we come off there just for a moment. There's an example here I sort of neglected with some apologies, but if we have a general rectangle, the area was length times width. And so we had done an entire unit on perimeters and areas and volumes. Nothing new in these first 3. Okay? Ephraim.
I had a problem last night. Last night's homework.
On 1-4? Okay, you're putting numbers in order. Which kind of numbers are you referencing?
Picking numbers divisible.
The median?
No.
Okay, I'm getting discussion here. I need to clarify. Emily, add to it.
It gave you a set of numbers, and it said, choose all the numbers in the set that are divisible by 2.
Yeah, my two, yeah.
Okay.
And then
Divisibility rules. Okay, let's
Yeah.
talk about that. This is where we had been before, and this is in 1-4, but it's an appropriate thing to answer. If I want a number to be divisible by 2, what do I look for?
even numbers.
The last digit. If the last digit is even, it's divided by 2, or divisible by 2. What's your rule for 3?
Anything that adds up as a...
Add the digits in your number. So example, if I have 2, 7, 2 and 7 is 9, 3 will go into 9, so 3 will go into my number.
These were the ones that were divisible by 3, 333, 111, 550.
Okay, but the point being, you can use that rule.
Same thing.
Now what about 5?
Same thing with five.
The last digit is 0 or 5. So you had to not only take the numbers, but then sort them.
No, not
We didn't sort them. We had to add commas.
Okay, what we're hearing again is this problem with what we call the grammar of mathematics. That is, did you have to have commas? Did you have to have decimal? Did you have to have a period? Did you have to have a dash? If you know what you're doing, then you're doing it, and you're convinced you're right, and the computer's not accepting it. There are a couple possibilities. The simplest one is you don't have it in the form it wanted it. So don't stress it. I'll give you time. Bring that in on Tuesday, and we'll look at it and try to get that straightened out. My guess is that it's just the form you're trying to put it in. And that, after a while, will get a lot easier. And maybe, if you get some time, sit down with a couple of you together. Rita maybe can help there, and with the idea that you see what form. Because if you know the divisibility rules, it should go okay. Now the question, do you have to have them rearranged? Michael's saying no. But you're saying when you tried putting it in, it rejected you. Don't take it personally. Okay? Don't take it personally. It just means there's some glitch, and we will try to handle that. And if you are really feel that something's amiss, maybe print out that page and bring it in, and we'll look at it. I'm worried about time element right here, and my intent was not particularly to get into 1-4 today. So, but nonetheless, I appreciate the question because I do have a quiz. That's only a 10-minute quiz. It's a short one. And so it'll take an extra 5 minutes beyond what we have. But I'm going to try to avoid having really long quizzes. These are pretty straightforward. I think 10 minutes will probably do it. You don't have to write anything down. It's written out for you. No, it's not open note, and no, it's not open book. You're going to have to enjoy the struggles without that. So, for those of you who've been watching, this is a little bit of the thing that we'll do. We'll have a lot of dialogue, a lot of noise. We'll have a lot of discussion, hopefully answer questions, not get everything answered. But it's been a fun hour. I've enjoyed it.